Hello students, good morning. Today we are going to see the continuation for the lesson 9. The topic is electrochemical cells. Okay. So first one is what is meant by electrochemical cell. So the name itself indicates that is electro mean that is electrical energy. So that is electrical energy. What is chemical? That is chemical energy. So what is here? The electrical energy is converted into chemical energy. The chemical energy is also converted into electrical energy. So that is called as electrochemical. So electrochemical, the name itself indicates electrical energy is converted into chemical energy. The chemical energy is also converted into electrical energy. So electrochemical cell, again it is classified two types. So first one is galvanic cell. Galvanic cell or otherwise called as voltaic cell. Voltaic cell, galvanic cell or voltaic cell. This another one is electrolytic cell. Electrolytic cell. Okay, what is meant by galvanic cell? So here also the chemical energy. So galvanic cell, the chemical energy is converted into electrical energy. So that is the chemical energy. Chemical energy is converted into electrical energy. Electrical energy is the best example is battery. So the process is automatically is taken. So it is called a spontaneous process. Spontaneous process. Okay, that is example. So that is galvanic cell. Galvanic cell is otherwise called as voltaic cell. So here that is chemical energy is automatically is converted into electrical energy. Is example is battery. It is automatically it takes place mean that is called as it is spontaneous one. So another one is what is meant by electrolytic. So that is the electrical energy. So electrical energy means the energy will supply for the conversion of this chemical energy. The electrical energy is converted into that is chemical energy. So here that is the electric current is passed through that means it will convert it into chemical energy. So that is, so here that is the applied energy will be needed for the conversion of this electrical energy into chemical energy. So this process is called this non-spontaneous process. Non-spontaneous process. Non-spontaneous process. So here that is the electrochemical cell. So next one is what is meant by redox reaction. So what is meant by redox reaction? So both oxidation, redox reaction, both oxidation and reduction takes place. So that is oxidation as well as reduction takes place. This redox reaction can be explained. The best example is called as Daniell cell. Daniell cell is the best example is the redox reaction is a conversion of oxidation. Both the reaction takes place in this cell. So here that is two half cells can be used. First one is here one half cells, here one half cells, here another one half cells. Here one half cells. It is made up of the solution. So the salt solution of zinc sulfate. This zinc strip can be used as a anode. Okay, that is zinc strip. It is acts as a anode, right? So this is anode. Okay, here another one is another half cells that is called as cathode. The solution is containing copper sulfate. What is the solution? That is copper sulfate solution. Here the copper strips can be used. So that is copper. It is act as a cathode. So anode is a negative charge. Anode is the negative. This will be positive charge, right? So first one, next one is it is connected with that electrical current, that is the voltmeter. So that is the apply external voltmeter that will be connected here. That is voltmeter, right? External voltmeter to measure the current, right? So here that is two half cells can be connected with the U-tube. That is U-tube, right? So here it is closed with that cotton plug. In this U-tube, what will be present here? that is here, that is agar-agar gel will be present. So here that is agar-agar gel. Agar gel will be present here. Instead of that, in this one, that is the inert electrolytes. That is, what are the inert electrolyte? That is potassium chloride or sodium sulfate can be immersed in that agar-agar gel. Okay. So why we are using that one? It will be slowly, when we are needed, mean it is slowly dissolved in the zinc sulfate solution. So here that is the U-tube. It is an inverted U-tube is connected. In this U-tube it is present in the agar-agar gel, right? So agar-agar gel, it is contain potassium chloride and the sodium sulfate is an inert electrolyte. What is that? That is inert electrolyte. Okay. Inert electrolyte. Here, first one is when is the current will be passed. What will happen? So when the current will be passed means, so here that is the first one is when compared to copper and the zinc, which one is more electrolyte? So here copper is the more tendency to pull the electron towards that towards itself. So that is the reason the zinc is remove that, lost that electron. So what is the nature? The copper cathode have the tendency to pull the electron towards that cathode. So what is that meaning? So here that is zinc. It will be the solid zinc. It will be lost that electron. That is 2 electron. So it will become Zn2 plus ion. So what will be the reaction? The removal of electron is called as oxidation. Okay, this is oxidation. The same thing. So here that is copper sulfate is here. The copper sulfate, how it will be dissolved? Cu2 plus and SO4 2 minus. So here that is copper sulfate. When here current is passed, mean it will dissociate into ions. That is copper sulfate SO4 2 minus ion. Here the Cu2 plus ion gain the 2 electron and it is converted into copper. The copper, the solid copper is started to deposit in the cathode. The solid copper is deposited in the cathode. So that is called as reduction. Okay, so this is the first one. This is the Daniell cell. So Daniell cell, once again, that is 2 half cell, that is anode and cathode. One that is anode containing zinc sulfate and the zinc strips can be used as an anode. Here the copper sulfate, copper is used as a copper cathode. Copper strip is our copper rod is used as a copper cathode. Again, first one is when it is connected with the external voltmeter. It is measured using that current, and again it is the U tube is inverted connected with the 2 half cells. That is called as, that is agar-agar gel. The U tube contain agar-agar gel. Inside that agar gel, the inert electrolyte that is potassium chloride or sodium sulfate dissolved in the agar-agar gel. So here, so first one is when compared to copper and zinc, copper has the more tendency to pull that electron towards that. So the zinc and less tendency. So that is the reason zinc started to lose that electron. So that is here the zinc solid is converted into zinc 2 plus and 2 electron. Here that 2 electrons are accepted by the copper sulfate. That is the, it is dissociate into copper 2 plus and SO4 2 minus ion. The copper 2 plus ion gain the 2 electron. It will become copper is the solid. The copper solid is started to deposited in the cathode. Okay, so this is the first one. Okay, so next one is at anode. What will happen at anode? Anode half cell. Okay, anode half cell. What is the reaction will takes place in the anode half cell? So first one is the oxidation will be takes place is the anode. Oxidation. Oxidation, the same equation we already told, that is zinc and solid is converted into Zn2 plus and the 2 electron. Again at cathode half cell, that is reduction. What is the reduction? Here that is copper 2 plus, the same equation, the Cu2 plus 2 electron gain, it will convert it into copper solid, right? Copper solid. Now we are adding the 2 equation, the 2 electron will be cancelled. So that is zinc solid and Cu2 plus it will convert it into Zn2 plus, that is aqueous solution, plus copper becomes solid. Okay. So after this is the net equation of this Daniell cell equation, that is the net equation. Now here, after the particular time, so here see the diagram. After the particular time, what will happen? After the particular time, the zinc dissolve in the solution. The zinc is become thin because the zinc started to dissolve in that zinc sulfate solution. So it will become very thin. So that is after that, here that is copper is deposited in that side. So here it will become thin. It will become thicker in the copper cathode because the copper is deposited in that one. So next one is, but in the after complete dissolving in the zinc strip means, that is complete the dissolving in the zinc sulfate solution, the reaction will be completed. So completed dissolved reaction, the reaction will be completed. So in this, what is mean by salt bridge? Okay, so here why you be using the salt bridge? So here again, what is mean by salt bridge? What is mean by salt bridge? So what is mean by salt bridge? Because Zn2 plus ion is equal to SO4 2 minus ion. So here that is Zn will be increases. So here that is Zn plus SO4 2 minus ion. Zn2 plus SO4 2 minus ion. Here also SO4 2 minus ion here. Here the Zn2 plus ion concentration will be more in that side. That side the copper sulfate, that is the zinc sulfate, that is the copper, the sulfate ion is increases in that half cell. So here that is zinc Zn2 plus is increases in that half cell. This one is sulfur 2 plus ion is in. So maintain to balance. So here that is Zn2 plus when compared to the starting stage, Zn2 plus is balancing the SO4 2 minus. After the completion, the Zn is more when compared to SO4 2 minus. So in order to maintain the neutrality, so we are adding already in the agar-agar gel containing potassium chloride. It will dissociate into K plus and Cl minus ion, right? So here, so the agar-agar gel, that is here containing potassium chloride, that is K plus Cl minus ion. Here Zn2 plus is more means the Cl minus ion is slowly dissolve in that solution to neutral this half cells. Okay, so here that is Cl minus ion is moving inside that solution to maintain the neutrality of this half cells. In that side, what will happen? Here again SO4 2 minus ion is increases. So here Cu2 plus when be decreases, Cu2 plus becomes Cu. So SO4 2 minus ion is increases. So what will be here? That is potassium. So that is another one is sodium sulfate is here. No, that is the sodium ion is slowly is move in that side to maintain the neutrality of this half cell. Okay, this is the three things. First one is here that the chloride ion is dissolved in that one to maintain this half cell. Here the Na plus ion is maintain this neutrality to dissolve in this SO4. Here SO4 2 minus ions is increases. Here that is Zn2 plus ion is increases. Okay, so that is that is the reason I am writing here. That is first in this one Zn2 plus when compared to Zn2 plus is more when compared to SO4 2 minus ion. The Cl is maintained the neutrality. The same thing SO4 2 minus ion is greater when compared to Cu2 plus. So balance this equation Cu2 plus ion. So here that is Na plus ion to maintain this neutrality. Okay, so this is the Daniell cell. So this is the salt bridge. We are using this salt bridge. Okay, another one is how to so how to cell notation, galvanic cell notation, how to write the cell notation, how to, the important one question, how to write the cell representation, how to write the cell representation of the galvanic cell notation. How to write the cell notation? First one is how to write the cell notation. Here one formula is here. So first Zn is solid in condition. Again that is Zn 2 plus ion in the aqueous solution. Again this is the represented is a salt bridge. Double line is represented as a salt bridge. So here that is Cu2 plus aqueous, Cu solid. What is the meaning for that? So here the left side. So that the above notation, the single vertical bar represents the phase boundary. What is the meaning for that? It is called as phase boundary. Phase boundary. So here this is also phase boundary. Phase boundary. So the double line is a double line represent is the salt bridge. The double line is represent is a salt bridge. Again, this is called as the left side. It is called as anode half cell. Anode half cell. Okay. So here this is the left side. Left side. So middle is a salt bridge. Salt bridge. This is salt bridge. That side this is cathode. Right. This is cathode. Cathode half cell. Cathode half cell. Okay, this is cathode half cell. This is right. Again, the standard EMF of this cell is, that is standard EMF, its notation is E0. It is equal to 1.1 volt. Okay, so this is the galvanic cell notation. The anode and cathode are written on the extreme left and the anode is written on the left side and the right side is cathode. The EM of the cell written in the right side after the cell diagram. So this is the cell diagram. The right side, you write this one. This is the extreme right. This is the extreme left. This is the galvanic cell notation. Okay. So sometimes they are asking what are the rules for the writing the cell notation. First you write the phase boundary. The vertical single line is called as phase boundary of anode half cell. This is the phase boundary of cathode half cell. The double line is indicated is the salt bridge. So it is right in the middle. So this is the EM of the cell. The electromotive force EM of the cell is right in the right side, left and the extreme right. The EM of the cell right side after the cell diagram. After the cell diagram, this can be written. Okay, so this is the galvanic cell notation. So next one is EMF of a cell. What is meant by EMF of a cell? Electromotive force. Okay, that is electromotive force. So what is meant by electromotive force? The electromotive force is the force that pushes the electron away from the anode and pull that towards the cathode is called electromotive force. So we already know that. So this is the Daniell cell. We already know that, no? So this is one half cells. So this is the salt bridge. So here that is anode. This is cathode. Cathode. This is one half cells. That is zinc sulfate. This is copper sulfate. So here this is both are connected with the, okay, so here the tendency, the force that pushes the electron. So here that is zinc rod is there. Here that is copper is there, right? So pushes that electron towards that cathode and pull that electron towards the anode. So that is that force is called as electromotive force. The otherwise the electromotive force is called cell potential. So once again, what is meant by electromotive force? The force that pushes the electron away from the anode and towards the pulls them towards the cathode is called electromotive force or cell potential. So here the energy can be measured as a joule, right? Energy can be measured as a joule. So that is 1 joule is equal to 1 coulomb into 1 volt. So the cell voltage, so here that is 1 joule. The energy is released for each coulomb. The charge moves between these two electrodes. So that can be calculated. 1 volt difference is electrical potential between the anode and cathode. So that is 1 joule of energy is released for each coulomb. It is the charge that moves between them. So that is 1 joule is equal to 1 coulomb and 1 volt. So these are all, everything is calculated under the 1 atmosphere standard STP. So that is at 1 atmospheric pressure. So this can be calculated. The cell voltage depends on the 3 things. So that is the cell voltage depends on the 3 things. Depends on, first one is nature of the electrode. First one is nature of the electrode. Nature of the electrode. Second one is concentration of the electrolyte. Concentration of the electrolyte. And third one is temperature. So what is the meaning for that? The cell voltage. So all the cells does not contain the same voltage. So because the cell voltage depends upon the nature of the electrode and the concentration of the electrolyte and the temperature of this solution. So that depends on the 3 things. The cell voltage can be varied. So again, the EMF of the cell, the standard EMF of this Daniell cell, the E0 value. So E0 value is equal to, that is one EMF value, that is 1.107 volt. So here, that is measurement of this Daniell cell using that one. How to write? Again the same thing. Zn S, then Zn 2 plus aqueous of 1 mole. Here, that is 1 mole of solution is converted into, that is aqueous solution 1 mole, and copper is become solid. That is the cell notation. The EMF value is equal to 1.107 volt. Okay, so at the EMF below mentioned, this is the Daniell cell of the cell notation, the EMF value of the Daniell cell. So now, how to measure this EMF of the cells? So, okay, how to measure the EMF of the cells? The overall redox reaction can be considered the EMF of the 2 hop reactions, right? The next one is measurement of this. Measurement of electrode potential. Electrode potential. Electrode potential. So the overall electrode potential can be considered the sum of the 2 hop reactions. So how to calculate? That is E cell is equal to E oxidation, right? Oxidation, it takes place at this anode, and E reduction, it takes place at the cathode. It takes place at the cathode, E cell. So what is EMF? The measurement of the electrode potential can be calculated, the sum of the electrode oxidation at anode and the reduction at the cathode. So the EM of the cell, E cell is the EM of the cells here. That is oxidation potential. This can be, it is not at all possible, it's calculated separately. So that is E oxidation anode. It cannot be calculated separately. So the single electrode potential is not at all possible. Single electrode potential is not at all possible. Combined together only we can calculate it. But in this but in some other way, we can calculate measure the potential difference between the 2 electrodes. So that is the voltmeter. So voltmeter, using this voltmeter, that is equal to the potential difference between the anode and the cathode. Difference between anode and cathode. The energy difference between the anode and cathode, we can calculate the measure of this electrode, that is the measurement of the electrode potential. So here we are going to see the standard hydrogen electrode, that is called as She. So next topic is standard hydrogen electrode. So now we are calculate the standard electrode potential using the She. She means that is standard hydrogen electrode. So here the standard hydrogen cell EMF is equal to the sum of the, already told, cell EMF is equal to the sum of the 2 half cells, sum of 2 half cells. Okay. So now using this reference electrode. So here that is two things. First one is reference electrode. Second one is what is the main purpose using this standard hydrogen electrode? It is act as a reference electrode, and second thing, it can act as a cathode as well as anode. It acts as cathode as well as anode. Okay. So, and also we are assuming the cell EMF of this standard potential hydrogen electrode, the She is arbitrarily 0. What is meant by arbitrary? Randomly we are assuming 0. So that is E0 value is equal to 0. So these takes place at 1 mole of hydrogen gas. 1 mole of hydrogen gas in 1 atmospheric pressure. 1 atmospheric pressure. So that is here in this She hydrogen electrode potential, platinum is used as a cathode. So that is platinum electrode can be used. That is 1 mole of H plus ions and 1 atmospheric hydrogen gas can be used in this She. Which cell you are going to calculate it means using this half cells. So suppose we are going to calculate the anode means in this cathode using as a reference hydrogen electrode. So suppose you are using cathode means in this anode you are using hydrogen as a reference electrode. So here, so this is the diagram of the standard hydrogen electrode. Here, that is the standard hydrogen electrode here. Now the hydrogen intake, hydrogen gases intake here, that is the tube is closed, in this hydrogen gases outlet. So in this solution, what is that solution? 1 mole of hydrochloric acid here, that is 1 mole of hydrochloric acid is there, that is platinum electrode is here. The hydrogen gases get inside mean it will be bubbles and go outside. So here what will takes place? It will takes place, hydrogen gas will converted into H plus ion and the 2 electron volts. So and the another one is reduction. Both the oxidation reduction takes place in this solution. So that is the thing we can use as a standard electrode. That is hydrogen is used as a standard one. So here now using this one, why we are using the hydrogen is a standard. It can act as a reference electrode. It acts as both it acts as a cathode as well as anode. The cell EMF is arbitrarily 0. So now at anode, what will happen at anode? Anode means that is oxidation, right? That is oxidation. What is oxidation? So at anode oxidation, so hydrogen gas in 1 atmospheric pressure will converted into H plus ion, that is 2 molecule of electron will be removed. So that is aqueous 1 mole of H plus ion. So balancing that 2 H plus ion, the E0 value we already assumed in hydrogen is a 0 volt. Okay. Another one at cathode. Cathode, the reduction will be takes place. Cathode, reduction takes place. What is the reduction? Again, the H plus ion, that is the reverse, the H plus ion gain the 2 electron, it will become hydrogen ion, hydrogen gas. So that is H plus ion gain 2 electron, it will convert it into H2 gas in 1 atmospheric pressure. Okay, this is also E0 value is also 0 volt. Okay, so this is the two things, so cathode and the anode. In this one, so using this at anode, what will the reaction will takes place? Hydrogen is converted into H plus ion. Cathode, suppose you are using as an anode mean this reaction takes place. Suppose you are using the cathode mean this reaction takes place. So this can be explained in one example. Okay, how to explain that? Let us calculate the reduction potential of the zinc electrode in zinc sulfate solution using She. Okay, so this is the constructed of the galvanic cell. So how the galvanic cell constructed, that is Zn 2 plus. So that is then left side is a anode. So anode la enna irukku ungalku zinc electrode irukku, inge cathode la enna irukku, that is the She irukku, that is standard hydrogen electrode irukku. So instead of anode cathode, so normala irukkiradhukku illama inge enna irukku, that is indha pakkam enna irukku, She irukku, indha pakkam enna irukku, indha pakkam vandu anode irukku. Okay, so now you are writing how to calculate. So EM of the cell, E0 cell is equal to, what is that formula? E0 oxidation into anode. Anode la enna irukku, Zn 2 plus, right? So plus E0 reduction, that is here, that is She. Okay, so we already know that E0 cell, that is E0 cell value என்ன கொடுத்துட்டோம் 0.76. நம்ம என்ன சொல்லிருக்கோம், E0 value She உடைய value always 0. We are assuming standard reference. So இதை நம்ம என்ன எடுத்திருக்கிறோம், 0 volt எடுத்திருக்கோம். So that is E0 oxidation Zn 2 plus. இது நம்ம என்ன எடுத்திருக்கோம், 0 எடுத்திருக்கோம். E0 value is 0.76 volt, right? So here, what is that value? So கேட்டிருக்கிறது zinc electrode, that is the reduction potential. Now E0 oxidation Zn 2 plus value is equal to 0.76 volt. Okay, so this is the one thing. Another one is using at anode. So இப்போ இங்க என்ன இருக்கு, anode தான் இங்க இருக்கு. So இங்க cathodeல She இருக்கு. இப்போ நம்ம இதை வச்சு கண்டுபிடிச்சாச்சு. Next என்ன பண்ண போறோம், anodeல. So anode என்ன இருக்கு, anode, what is the equation in the anode? Zinc solid is converted into Zn 2 plus 2 electron. Okay, what is that? E0 value is equal to 0.76 volt. Okay, so in the reduction potential, what will happen? So this is the anode, it takes place oxidation. What is reduction? The equation will be reversed. So what is the reduction potential? This is oxidation. What is reduction? The reaction will be reverse. Zn 2 plus 2 electron gives Zn solid. So here, suppose you are reversing that equation, means you are reverse that sign also. E0 value is equal to minus 0.76 volt. Okay, so this is the way you are calculating using the standard She. So standard hydrogen electrode, using that one we can calculate the EM of the anode, reduction potential of anode or cathode. So we can easily calculate it. Okay, hope you are understand. Thank you children.